So think of it this way: it'll make for good stories in 10 years or something like that. Now, do you want to recognize your own questions, or you want me to do that for you? Do you care?
Sure, I'll field my questions.
Okay. Well, we're going to start with Walter Barta, and I'm going to let every speaker say whatever they want to say about themselves for time's sake. Take it away.
Yeah. Actually, before we get started, I have handouts. If we can, thank you. So the handouts actually, they just have a summary of the argument on the front and then gibberish on the back, because I was trying to conserve paper, so I just used what I could, which could be anything, by the way. Don't sell my credit card number if it's on there. It probably won't be, but so I'm Walter Barta. I'm from the University of Houston, and I'm a grad student in the Digital Humanities program there. And I'm going to present on the Grabby Aliens Hypothesis, specifically something that I'm calling the Grabby Aliens Observer Paradox. So I assume everybody here probably has heard of the Grabby Aliens Hypothesis. But as a refresher, so it was a paper published a couple of years ago now by Robin Hanson. He's like a futurist guy, really interested in robots, aliens, all that kind of stuff. And it sort of his paper, which is a very academic paper, blew up sort of in the meme sphere. So there are YouTube videos about it, podcasts about it. And I kept getting bombarded by these, like in my recommendations, right? And I thought to myself, well, I've listened to this theory probably 100 times now. I should write down what I think of it. So that was sort of the impetus driving this paper. So, okay, let's define what the Grabby Aliens Hypothesis is, though. So the basic idea behind the hypothesis is that humans are too early, the theory goes. So we look at the fact that we live on a planet orbiting a yellow sun, and we look at the age of the universe that it currently is versus what the age of the universe could be potentially. And we think, okay, we're pretty early in the scope of things. One of the driving thoughts here is that if life can emerge from a planet that circles any star, why are we on this relatively early star? And why are we circling around what's considered a short-lived star, right? So the sun, relative to other kinds of stars, is significantly shorter, specifically shorter than red dwarf stars in its life expectancy. So why are we orbiting that kind of star, and why are we so early is sort of the puzzle that the hypothesis is trying to solve. And the idea is that the reason we're so early is because Grabby aliens. That's why we're so early. So what's a Grabby alien? The idea is that eventually, at some point in the history of the universe, life forms will start expanding off their home planet. And once they start expanding off their home planet, that sets a cosmic deadline. Because they're expanding now, and if they can expand faster, then new life forms can emerge on those planets that haven't given birth to life yet, then the expansion will actually swamp out the universe, and there will be no more life after that. So that's the basic idea. So let's define some terms first. So we have these yellow guys are us. We live on Earth with a yellow star, right? So there's also potentially creatures like us that live on planets that orbit red dwarf stars. So those are these red guys. So we'll call them late-time, long-lived red dwarf observers. And then we have Grabby Aliens observers. So those are these gray guys. I made them gray because it's kind of a gray area whether they could exist. There's another reason too, which is they may be robots. There's maybe good reason to think they're robots, but that's speculation as well. So we also have to define what we call our reference class. So Robin Hanson assumes that we can treat observers as part of a similar reference class. So we yellow sun observers can be part of the same reference class as red dwarf observers as well. So it's like we can put a big circle around ourselves and around those red dwarfs, and we can count ourselves as the same type of thing, which is sort of like, you might define it as like intelligent life forms that can observe the cosmos or something like that, right? So to get his theory off the ground, that's one of his starting assumptions, is assuming a common reference class. And we'll go into the difficulties of that later. So basically, what's the situation we find ourselves in? We find ourselves early in time, orbiting a yellow sun, right? And the implicit idea here is we take something called the self-sampling assumption. The self-sampling assumption is the idea that you can use yourself as a data point to sort of try to make conclusions about what the rest of the population might look like. So if we are a yellow sun observer, we can sort of say, okay, well, maybe if I randomly select from the observers out there, maybe I'll pluck out a yellow sun observer. That's sort of one of the assumptions Hanson is making. And so this intuition, you can make this intuition in other contexts. So we're at a hotel, right? Or a hostel, I guess is what it is. So imagine they randomly assign you a room at the hotel. And it just so happens to be a yellow room. It's painted yellow on the inside, let's say, right? But then you learn later, talking to everybody else at the conference, you learn later that everybody else is in a red room. You're the only one that got assigned to a yellow room. So you might find yourself thinking, okay, that's a little bit improbable. Like, most of the rooms are red. I just so happen to be assigned to a yellow room. And that seems like I sort of won a mini lottery, so to speak. So that's sort of Hanson's initial intuition, is why did we win that mini lottery? So Hanson thinks that the universe might actually look like this, which is to say that the observer reference class is dominated by red dwarf observers. That's his thought. And he thinks this because he thinks that red dwarfs might actually be hospitable. Those solar systems may be hospitable in the same way that ours is hospitable, he thinks. And he gives a lot of complicated mathematical justification of this, which I'm not going to go into here. But he concludes basically that under conservative assumptions, this is what we think we should see. Okay, so then the natural question after seeing this would be, oh, so why are we seeing ourselves as a yellow sun observer? Shouldn't we just, if you drew us out of a hat, shouldn't you see us being a red dwarf observer? So the idea then is to propose the Grabby alien model, which looks like this. So you have a life originating planet, and then boom, they expand to fill the entire universe. And then from then on, it's Grabby aliens, basically. The future is Grabby aliens. That's his basic mode of thinking. So what I think that the idea here is plausible, but I think my take is that you have to bite at least one bullet and make at least one philosophically uncomfortable assumption to get here. And so that's what I'm going to be talking about for the rest of the presentation. To summarize the difficulty that I'm going to be going over, so I think that one of the worries is that Hanson never makes a certain justification about why he defines his reference class in the way that he does. Like I said, he defined the reference class with yellow suns and red dwarfs. But the issue is that you could also include other observers. You could even include the Grabby aliens themselves. So if I went to that same hotel that I mentioned, and they randomly assign me a room, I get the yellow room again, and then they tell me, look, we just put on a huge addition to the hotel. It's much bigger than the hotel was last time you came. But you happen to not get assigned to that addition. You happen to get assigned to the yellow room again. So then you might ask yourself the same question, the same puzzling question of, okay, well, why was I in such a improbable position again? So let's go into.
Excuse me. Comprehension question. And so the Grabby aliens, do they colonize, settle other solar systems? And if so, do they settle yellow stars or red stars? What do they do?
Yeah, so the Grabby aliens expand to fill space, including niches like yellow suns and red dwarfs. Yeah. So here's the purported paradox, is that if Robin Hanson thinks that it has to be the case that there are more yellow sun observers than red dwarf observers, then we have to have Grabby aliens. But then the problem emerging from that is, well, if we have to have more yellow sun observers than Grabby aliens, then we can't have Grabby aliens. So that's the puzzle to solve. So there are a lot of ways to solve this puzzle because there have been a lot of assumptions made. So we just have to give up one of those assumptions to try to solve the puzzle. But all of the assumptions kind of come at a slight cost. So the first objection, I call this objection 0. It's reference class choice. So Robin Hanson is making an assumption about what gets to be included in his reference class. So if we think of the different categories of observer we've listed, there are different ways to define our reference class, right? So we could go with a principle of generality where we include everything, or try to include everything, at least all observers, right? That would be like the most general possible choice. We also could go with specificity. We could just say, well, the reference class is us. We can't make any like assumptions beyond that. We're not entitled to that philosophically. So those are two possible counter assumptions which Hanson is not making. This specificity argument, I think at least some astronomers have made the case for this. I think Sean Carroll might be one of them. So what is Hanson saying? He's saying we draw the boundaries like this, yellow sun and red dwarf. But as I mentioned, you have to justify that. You can't just postulate that without justification. Because otherwise you could potentially just postulate this without justification too. So we have to come up with a way to make such a justification warranted, or else you end up possibly just assuming all of these. So each one of these could count as a reference class, and we're just applying each one separately. So if you applied specificity, you could conceivably just apply each one and come to a different conclusion each one, and each conclusion might be justified in the same way. So so like I said, this is what Hanson's reference class looks like. This is what a general reference class would look like. This is what the specific reference class would look like. And then you could choose an adjacency reference class. So the other objections are sort of going to fall into sort of categories of justification for why you might choose one reference class over the other, basically. So the first possible objection, you could say, we are not yellow sun observers. So this one doesn't seem prima facie plausible, right? Because we look out the window and sort of can refute it. But at least sort of if you are wanting to be inclusive of all possible objections, this one is one to start with. The reason you might start with this one, even if we sort of are not radical skeptics who want to doubt what we see directly astronomically, we can object to sort of the self-sampling assumption premise. So we can say, no, we're not actually entitled to that premise in the first place. So this entire line of reasoning that Robin Hanson starts with, we can push it to the side as not a good line of reasoning. Another way to reject the self-sampling assumption, if you want to keep these kinds of anthropic reasonings, is you can propose a different kind of assumption here. So another famous one is the self-indication assumption. It's similar, but with different wording. We don't have to go into it unless if somebody has questions later, we can go into that one. But if you assume something like the self-indication assumption, you then are tasked with the baggage of biting that bullet instead. So yeah, this is a bullet that we're biting that we don't necessarily have to bite. But like I said with the hotel example, a lot of people do have this intuition of the self-sampling assumption. The third way to do this is that we are just improbable. We could just bite that bullet. We could just say, yeah, we see a yellow sun and we find that to be a rare case in the cosmos. But somebody is the yellow sun observer, right? Presumably, as long as yellow sun observers exist, there's one of them. So we might just be the improbable one. And that could be fine. We could be fine biting that bullet. So another possible line of objections is we could say there are no red dwarf observers. So this objection would be that we either reject red dwarf hospitality, which is to say red dwarf systems are super inhospitable. We'd reject that entirely. Or we could reject something else, which is the hard steps model. So the hard steps model is this model of evolution that proposes that evolution goes through these hard steps. And the hard steps model sort of implies that the longer the planet lives, the more chance there will be of life, which seems intuitive, right? But if we reject that genre of models, then we can sort of get rid of the intuition that a long-lived planet will have more life. And then we can say, well, this supposed problem that we are early, it's not really a problem at all, because those red dwarfs, they don't have life anyway, and we can just sort of put them as the improbable case of not really having much life. So that's another option. So this option, there's credence to this option because there's been a lot of studies about how red dwarf systems may actually be super inhospitable. There's a few reasons for this. One of the reasons is the spectrum of light emitted by red dwarf stars versus the spectrum emitted by yellow suns. Another reason for this has to do with the types of planets that we observe around red dwarfs and how there's certain features of those planets that don't seem hospitable for life. So for example, those planets are observed to have tidal locking. So that might be inhospitable to life. Those are just some examples. But this also, even if we accept this, or rather if we reject red dwarf observers, we're still sort of left with a puzzle. Okay, well, we still could have all these Grabby aliens out there. So even if there aren't any red dwarfs, there may be Grabby aliens still. This just happened to be Robin Hansen's justification for proposing the Grabby alien hypothesis, but you could have Grabby aliens without this justification, right? You could just have us, like we could expand and become the Grabby aliens, and the red dwarfs could have nothing to do with it, basically. Okay, so that's the second line of objections. So here's the third line of objections, which is there are no Grabby alien observers. So this is the most sci-fi kind of fun line of objections. It gets kind of interesting. So the first one would be that the Grabby aliens engage in some kind of extermination event. So some of you probably have heard of the doomsday argument. This is sort of in line with a version of the doomsday argument, which says that, you know, we observe ourselves to be at this time and place in the universe, and from that fact we can sort of make this inference that, okay, well maybe because this is where we find ourselves, doomsday will happen soon. The reason being that, like, we would be the largest sample size, and if there are no sample sizes larger than us, then this is sort of as big as it gets, so to speak. But so this actually, the doomsday argument doesn't cut it here, though, because you wouldn't just want to say that, like, planet Earth will extinguish itself. You would have to say something like, all of the Grabby aliens always extinguish themselves, which starts to become a really, that becomes a tougher bullet to bite unless you can propose some mechanism by which that would be true. So that one seems a little bit tough to swallow. The other idea would be that Grabby aliens don't reproduce very much, so they end up not actually being a dominant sample in the reference class. The trouble with this one, so I guess you could imagine aliens not reproducing very much, but the irony of this one is that these aliens are supposed to be grabby. They're supposed to reproduce. They're supposed to expand as much as possible. So you'd have to simultaneously propose that they're expanding as much as possible, and you'd have to propose that they, like, don't really reproduce very much. So are they using technology to expand without themselves expanding? What's going on there? You'd have to answer some kind of question like that. And the last one, I saved this one for last because I think it's the funniest one, is that the Grabby aliens are zombies, which is to say that they don't count as observers in some sense. So the idea of a philosophical zombie, right, in like the David Chalmers sense, is that they are intelligent creatures, but they don't have phenomenal states. But so they are like intelligent creatures that then wouldn't count as conscious creatures like us. So we get to exclude them from the reference class of observers. So would Grabby aliens be like that? So presumably, if they're navigating the universe, they're like observing what they're navigating. So that's its own bullet to bite, because we'd have to say in some sense these count as observers, but then they don't really count as observers in the same sense that we do, which is kind of strange. So that one we can sort of put that as a different kind of bullet to bite, maybe a theory of mind bullet to bite. So, and this is a sampling of the possibilities. I don't claim this to be exhaustive, but the argument basically is that if you're Robin Hansen, or if you take the Grabby alien hypothesis seriously, then you have to be accountable for explaining why, which one of these would be the assumption that you would have to have to give up essentially. And the trouble is, unlike let's say the doomsday argument, the assumption of anthropic reasoning, which is the self-sampling assumption that we started with, that assumption is baked into his theory. That's where he starts from. So his theory, in that sense, has to explain why that self-sampling assumption is valid, or just why anthropic reasoning in general is valid, or else sort of it bites its own tail, so to speak. So, and I don't claim to have strong opinions about how to solve the issue, but I'm curious if anybody has strong opinions one way or the other. So, yeah, so that's it.
Questions?
So I want to thank you for bringing this to my attention, because I had no idea about the Grabby Alien Hypothesis. But it strikes me as, I wonder, does the paradox go away if we have a sort of causal story to tell, which is that, and when I'm listening to your talk, I'm in my mind making some assumptions, and if they're wrong assumptions, just like let me know from the beginning. So is the idea that if you have a red star, that more Grabby aliens will come from red star, or that the red star galaxies will produce people that can leave their planets because they have longer time to sort of gestate and develop the sort of technology and intellectual systems to be able to leave, as opposed to yellow stars, which are young and have less time. Therefore, there's a lower probability that you're going to have organisms that develop on this planet that can leave, right? Is that the kind of basic assumption?
Yeah, so you could imagine just sort of a bag of marbles, and you're plucking from the bag of marbles, right, and there are just like a few yellow marbles and lots of red marbles is the basic starting assumption, yeah.
Because then my supposition is then Grabby aliens have to come from somewhere.
Yeah.
They don't sort of materialize in space. So then the probability is that they come from red stars as opposed to coming from yellow stars.
Yeah, that would be.
So doesn't that then take care of the problem of the paradox earlier? Because then, therefore, there would be more Grabby aliens, and they would be from red stars. So I mean that, like, you would have to sort of label the Grabby aliens like red or yellow, and right, because there'd be a higher probability that a Grabby aliens would come from the red than they would come from the yellow.
Yeah.
And so does that solve the problem, or am I just making it way more complicated?
So it is complicated. So I see where you're going with it, though. So instead of classing the three classes that I've put, you could have the Grabby reds and the Grabby yellows.
Right.
And then what you would be put in the position of maybe having to say, it sounds like, is the Grabbies. If the red dwarfs really produce all those Grabbies, then
Or more Grabbies than yellow stars.
yeah, so then we would expect then more red Grabbies, I think. So that doesn't so I'm with you. I'm in line with, like, we could rearrange it like that. What would Hansen say? So I think it doesn't solve Hansen's problem, because Hansen would still think, well, why are we on a yellow star, if that makes sense? Because he would say we're the random data point plucked. So are we just the improbable yellow star, or are we?
We could be, but we're the only data point that we know.
Yeah, definitely.
I don't understand why they get so hung up because plucking a single ball from a bag full of bunch of balls is not, I think, the correct metaphor for this, because every intelligent species presumably sits and thinks about the universe, which means even the improbable ones will sit and think about the universe. Are all of the ends of the bell curve just always drawing the wrong conclusion about the universe? Or are some of us just improbable? I guess what you brought up was one of the first potential objections. That seems like such an obvious.
Yeah, and maybe, I mean, That's one of the more down to earth solutions is to just think, oh yeah, we're improbable. It's not a big deal.
Because some improbable intelligent species presumably exist unless we're all identical. So
For sure, yeah.
some of us in the universe are always going to run into that issue.
Yeah. So I think I saw a hand back there first.
I have a similar concern to Erica in that there's nothing unusual about being the first person off a plane, because somebody has to be the first person off a plane. Are you improbable for being the first person off a plane? No, you're just the first person off the plane from a large selection of other people that happen to also be on the plane. And in the same respect, I don't get this Hansen's issue here, because there exists life around the yellow star. We know that because we're it. We're not nothing improbable about it because we're here. That there exists so few yellow stars is irrelevant, because life did happen to exist here. There's nothing special about it. A more interesting question would be, why is it possible that there exists life around red stars? Is there something peculiar about red stars in virtue of their temperature or color or whatever that stops life from generating? That would be to turn the question on its head. So, and also we don't mention anything about the 15% of orange stars that there are in the galaxy, and the 4% of the blue stars, and the potential life around quasars and all these other sorts of things. So there are many more alien colors, I think.
For sure, yeah.
I can actually offer some explanations to these questions. So the assumptions in the model are not related at all with respect to the habitability of the planets around the stars. They are only related with the time, right? So all the assumptions are with respect to time in terms of like, universe time and the universe in the stars, right? So red dwarfs by definition live longer than yellow suns, right? So no assumptions with respect to habitability. Now, why do we make assumptions about habitability of just the red dwarfs and the yellow suns? It's because only around these planets there can actually be astronomers, astrophysicists, biologists, geologists have long looked at what constitutes the habitability band for a planet around these types of stars. And these are the types of stars more likely to have habitable planets around them, right? So that's why we don't make any assumptions with respect to habitability around a pulsar or habitability around, I don't know, like different class of stars. So even just these two, where the current habitability models are predicting that we only have these two types of stars where we're more likely to have habitable planets, it makes no assumption with respect to the planets themselves. So it's just civilization versus star, right? No planets involved. So he's looking only at the time dimension of the galaxy. So it's not the entire universe; it's just our galaxy, and how the so the question here, are we more likely to have occurred as an intelligent civilization in the beginning of the universe or in the late part of the universe, given this time expansion? So these are the only assumptions he's making. And it's like, 4 billion years right now. Is it early or is it late, right? In terms of civilization expansion versus universe expansion. And these are all the assumptions he's making, and then he's making a lot of simulations with, that are simply based on stochastic models, and trying to find those curve areas where you are more likely to have the kind of first of all, where are we placed in those curves in terms of early versus late, and where other potential civilizations are placed there. So that's kind of like the whole gist of the Grabby Aliens
Right, but he seems to
hypothesis.
reject the possibility that we're on one end of a curve and that the bulk are in the middle. Maybe he isn't with the answers, but
That's not,
he
he doesn't make that as a hypothesis, it's actually a conclusion from the assumptions and the premises that he's making with lots of simulations from different stochastic models. So, and I mean, he was my professor. So,
Awesome.
So yeah, and I have talked to him about this, and yeah, yeah, I think he's also the author of the brain failure, by the way, idea. So yeah.
I'm aware of the temporal element and the justifications for that, but that seems to presume that life develops at a certain epoch,
No,
because it privileges past time having been relevant in the development of current
Yeah.
species.
So you're probably guys are familiar with Nick Bostrom and his hypothesis that we live in a simulation, but he also has another work with respect to how many people have lived on Earth until now versus how many people are going to live on Earth from now on, right? So are we right now in 2024? Are we like in the beginning or towards the end, right, of our civilization? So he's actually making an expansion from Nick Bostrom's philosophical model with respect to our own lives within our human civilization towards, the Grabby Aliens Hypothesis. So it's kind of an analogy, speaking of analogies there.
Is Hansen with the Future of Humanity Institute?
Yeah.
Well, thank you for that.
Sure.
It's great that we have somebody here who actually has talked to Hansen. So,
I'm just curious, what is your personal view on this? Are we early and first, or are we late and last? Are we the Grabby aliens? Have we actually already ruined everything for everyone else? What's your personal view? What are we?
I knew that question would probably come up. So, so here's the. I might actually say, I sort of suspect that all of the assumptions that I've listed may have problems. So the first assumption. So we're taking ourselves as yellow sun observers and using that then to infer something about the whole rest of the reference class. That self-sampling assumption has, like I mentioned earlier, it has alternatives, and one of the alternatives renders it moot. So, like if you assume the self-sampling assumption and the self-indication assumption, which I didn't talk about, but it's a different version, then these kinds of reasonings just they collapse because one implies one way and the other implies another way, and then you can't really make a conclusion about it. So that's a real problem in the whole line of reasoning. But then it's sort of like, well, okay, people like Hansen are going to have trouble saying anything. So that's sort of like in a way, I don't want that conclusion to be true, because then I want to be able to say something, but then maybe we can't say anything. But so that's one possibility, is something like that. The other thing is the red dwarf inhospitability. It seems like that there's strong evidence that red dwarf systems are pretty inhospitable, and then that would cover that would like answer Hansen's concern in a different way, because then we're just saying, yeah, we're the most, yellow suns just happen to be the most hospitable possible solar system, and that just happens. That's just the physics of it, basically. Which answers his question, but then you could still ask the further question of, are there really Grabby aliens out there? Which is an independent question, and that's sort of like that question could be answered by the first thing I said, which is the problem with anthropic reasoning. We just can't say anything about it. I'd like there to be an answer, but it's one of those things where it's like unknown unknowns. I do suspect, so if there are Grabby aliens out there, I do suspect that they may be radically different from us. So they may be something like what we call a von Neumann probe or something like that, where it's essentially just they sent an unmanned satellite out into space, and those satellites sort of like constitute the majority of interstellar objects or something like that. So I'm not saying I lean towards the grabby zombies, but those might be grabby zombies. And that's sort of that's one other thing that I sort of consider pretty reasonable. Like, it seems reasonable that spacefaring civilizations would do a lot of von Neumann probes. So, yeah, but I'm pretty open to arguments about all those things. And one of the reasons I sort of don't draw a specific conclusion here is because of the nebulousness of the entire line of reasoning. So, anyways,
Okay, I think we're probably out of time. So thank you very much.
thank you.
One of the nice things about this conference is there's lots of opportunities for informal get-together. So you can yell at people all you want to.